Hello everyone. In my previous video, I have discussed about Google Gemma, which is a new state-of-the-art open source library released by Google very recently. And I have also discussed about how you can use it in Hugging Face chat, in chat prompt, and also how you can use it in single GPU or in multi GPU using your Python programming language. In this video, I am going to show you further implementation of it using quantized version and also for fine-tuning Gemma model. So before start, let me give you a short introduction about myself.
Welcome to AT Academy. The main motto of this channel is AI for Aam Janta. My name is Dr. Ayan Devnath. I am an IIT Delhi alumni and Fulbright research scholar at Harvard University. I have total 9 plus years of experience in the field of artificial intelligence, deep learning, machine learning, NLP, generative AI. Let's watch this video. Welcome to my metaverse.
My previous video where I have discussed about the Gemma models and how good is this model with respect to the contemporary state of the art models like Mistral, Llama. Llama is a model built by Meta and it is a very good model. Even Mistral is also an open source model. These models, Mistral and Llama, is performing very well. But when Google launched this Gemma is outperforming all these models with respect to different benchmarks, and I have discussed about these things in details in my previous video. You can go to my YouTube channel and you can get these videos and you can watch this video. I have made this video in an English version and I have also made this video in a Hindi version. I have discussed how you can use this Gemma model on a CPU, and if you want to use it on a multi GPU, then how you can use it. Now, in this video, I will be going to show you how you can use the Google's Gemma model in a quantized version. If you want to know about the model, then you can go to the Hugging Face. In Google, you can type Hugging Face Transformer, and then in the model section, if you go and if you type here Google Gemma, then you will find lots of Gemma models. There are four varieties of Gemma models. One is basic base models, 2B and 7B, and other two are instruction fine-tuned model, which are 2B IT and 7B IT. You can easily download this model and you can use it for your own purpose. For using it in a quantized version, it means that these models are in Hugging Face Hub and you can download it, but you can download in a smarter way. I will tell you what is quantized version of it. So here, before starting, I will tell you what are the libraries you need to install. First of all, you have to install bits and bytes. This is for quantization purpose. PEFT you will be using for uh, fine tuning of your model by using parameter efficient fine tuning technique. Then you can use TRL. This is for supervised fine tuning models. Accelerate dataset we can use it for if you want to download some dataset from Hugging Face and if you want to fine tune your Gemma models on that datasets, and then we will be using this transformer. If you just install transformer, then it will install 4.37, which is an older version, but you have to use this version, which is an upgraded version for your Gemma model. Once you install your required libraries, then you have to import certain libraries such as this transformer torch, because we will be using PyTorch as a framework, backbone framework. And then also we are using user data so that you can access that token to your Hugging Face into your Google Colab environment. Then load dataset is to load the dataset from the Hugging Face library. And then SFT trainer, this means that supervised fine tuning. If you want to do fine tuning in a supervised fashion, then you can use this model. And then also we will be using LoRa config, because we will be ultimately using LoRa technique to do fine tuning. And we have to use this auto tokenizer and auto model for causal LM. I have discussed about these two model in details in my video. You can refer to my video, and I will also give the link in the description box from which you can just click and you can watch that previous video. And then we are also using this Gemma tokenizer because we can use the tokenizer technique which is actually used to build Gemma models. So you can use Gemma tokenizer. Apart from this, you can use other kinds of tokenizer techniques also. And this bits and bytes config model we will be using to define few parameters for the bits and bytes. Now, first of all, you have to access Hugging Face token. For that, what you need to do, you have to go to your Hugging Face. So you'll write about Hugging Face transformer in a normal your search engine, and then you have to go to your Hugging Face profile. Inside your Hugging Face profile, you can go to this access tokens, where you can generate your new tokens, and that new token you have to copy, and then you have to place it here. Here you will find there is a key, and in that key you have to write that token value which you have copied from here, and then you have to write the name of the token. I have discussed about these things in details in the previous video, so again you refer to that video. And then once you have this access to that token, then you can get this token. You have to change the OS environment and you can get this token, so that you can have the access to the Hugging Face. So Hugging Face will know like which models you are downloading from which Hugging Face profile. How you can use the quantized version of the Gemma models for your case. So here we have to define the model name or model ID. So I will be using this Gemma 2B. As I mentioned, there are 4 varieties. I will be using this variety. Then I am defining few parameters like load in 4-bit equals to true. So it's a boolean where you can measure it as true and false. Why I am using load in 4-bit as true? Because whenever you will be downloading the model, actually, then these models having lots of parameters. It has 2 billion parameters, which is a huge number. And the parameters are what? These are the weights and the defined biases. And these weights and biases are in floating point 32 bits precision. So it will be a huge number. So it will be 0 point. Then there are 32 bits or 32 values after decimal point. So it's a huge number, and when you have lots of parameters, so these huge number when again getting multiplied with each other while doing backpropagation techniques, then it will be a very huge number, and we don't want to use that huge numbers. So we can decrease that floating point 32. From floating point 32 we can decrease it to floating point 16. Even you can decrease it to integer 8. Then the overall weight or the overall biases and overall size of your model will get decreased. If you use floating point 32, then the model size will be very high. And if you have shortage or some constraint in computational resources, then you can use smartly this Gemma model, but in a quantized version, where this floating point 32 can be decreased to floating point 16 or maybe to integer 8. So it's a quantized version, and the model size will be decreased, and you can easily use it, and you can use it for your training, for doing some fine tuning. And that is why I am using that load in 4-bit equals to true. It means I am decreasing that 32-bit to a 4-bit. Now there is one more parameter, BNB 4-bit quant type, which is NA4. So it means that it is a 4-bit normal float, and it is a technique which is used for quantization. Again, we are using BNB 4-bit compute D-type. This is another parameters where I am using this torch framework or PyTorch framework, and then I am mentioning it as floating point 16. So it means that though you have trained your, though you have downloaded your model in a quantized version from floating point 32 to say integer 8 or floating point 16, or from 32-bit to 4-bit, so due to this quantization there is a loss of information. And to balance that, when you are doing fine tuning, you can use floating point 16 for your weights while doing the fine tuning. And then we will be using this tokenizer and this model. So this is the common step which we are doing for others kind of fine tuning also, or even when you are calling a model and then you can use that model. So these two steps are the very common steps. So what we'll be using, we have to define the tokenizer. So I'm using this tokenizer from pretend, and here I'm mentioning the model ID. So my model name is Gemma 2B. So the tokenizer with respect to the Gemma model will be initialized in auto tokenizer, and then you have to define your token. So here I am mentioning this HF token. So it will state that which token you are using for fetching the module from the Hugging Face website. And then you have to mention this model for which you are mentioning auto model for causal LM. Causal LM means your causal LM is a causal language model. It means that when you are generating your text for decode based transformer models, so for that time we are using causal language model. We will be using this, and then here also we have to define the model ID. So Gemma 2B we are using, and here we have to do this configuration parameter. So in this configuration parameter, while downloading the model, use this configuration parameter, and you have to use this BNB configuration. So BNB configuration is this configuration which we have already discussed. Like BNB configuration is these bits and bytes where it is actually downloading the model in a quantized version. And then we are using device map as 0, so it means we will be using GPU, not CPU. We will be using GPU. And finally, we have to also use these token parameters to have an access to the Hugging Face. In that way, we can define the tokenizer and the model. So once you have defined it and you have executed it, it might take 1 or 2 minutes to download the model. And you can see how this model is changing or changing the RAM, how much RAM is taken, how much disk is taken. So you can go to this thing and you can click it. And one more thing is that you can change the runtime. So you can change the runtime to T for GPU or TPU in spite of CPU, so that your execution will be much faster and even it will not get out of memory. Now here I can write some text like tell me about Sachin Tendulkar. So these are text, and when I want to generate some more text on the top of it, I will be using this GPU and then I will be using this tokenizer. So computer don't understand any textual data. Computer understand numbers only. So if you directly pass this text to your model, then it will not be able to understand. So what you need to convert this text into some numbers. And how you will do? You will do using tokenization technique where it will create tokens IDs, that is some numerical representation. That is why I will be using this tokenizer. This tokenizer is same which I have already defined here. So I will be using this tokenizer on the text, and then I am defining few more parameters like return tensor equals to pt. So it means that it will be returning after tokenization, it will be returning the output in PyTorch framework. And these two device means I will be using my GPU device. If you don't mention these two device, then it will be using CPU, but I want to use GPU. So this will be my input and I will pass it this input to model.generate. So my model will generate on this text or on this token IDs. And I have to also mention one more parameters, which is a generative configuration parameters. There are lots of generative configuration parameters. These parameters are used when you are generating some text. So at that time you have to mention few of the parameters, and I have already made one detailed video about these generative parameters. You can go to my YouTube channel and here you can find these generative configuration parameters both in Hindi and also in English. So this tutorial 17 and this tutorial 18. And moreover, I will tell you this is a very important things interviewer can ask you about what is configuration generative parameter, what are the common parameter which we generally use. So it's better you refer to that video and you know about it before going for some interviews. Now here I will be using this max new token as 20. So it means that whatever my model is generating, so the maximum number of the tokens generated or maximum number of the words will be in 20. So whatever my model is generating, the maximum length of that generation or maximum number of words will be 20. And then whenever my transformer based model, so these are all transformer based models, so whenever my Gemma or these models will generate something, it will generate in a kind of some numbers, because that passes through softmax and then it will generate some numbers, and we have to convert those numbers to words. For that we'll be using tokenizer and we'll be using a decoding step. That's why we are using tokenizer.decode and then output 0, because it will be generating a list, and from that list I will be using my first element of that list. That is why my index is 0. And then we are using the skip special tokens. So if there are some special characters, then it will skip those tokens, and it's a boolean. That's why we are mentioning as true. And while you execute these things, it will tell you about the text which you have already mentioned. It will try to generate on the top of it. So I mentioned tell about Sachin Tendulkar. So this text came and then it is trying to generate something on the top of it. Say here I am changing the maximum new tokens as say 50. So let's try it out and let's see how is it coming. So this generation might take some time. It depends on how much RAM is available, hard disk is available. Okay, so here it is telling the famous Indian cricketer, underline the correct form of modifier in parentheses, example this. Okay, this is generating something wrong, but yeah, so if you fine tune this model, now this is the quantized version. So this is the base model 2B. So as I have mentioned here, so this is the base model which I'm using. Now you can use this base model and you can fine tune with your own data, and then if you use this text, then you will find your model is generating in a better way. So I will be creating one more video where I will discuss about how you can fine tune using LoRa technique. So stay tuned, subscribe to my YouTube channel and hit the notification bell icon so that whenever I will come with a new video, you can notified and you can watch that video. Kindly share this video with all of your data science enthusiast friends who are preparing themselves for some data science interviews, or those who want to know more about the generative AI, large language models, NLP, and they want to skyrocket their career in this field. See you soon in my next video.